Law of Cosines. First thing I think we should do is derive the formula. Suppose we have this triangle. It's labeled A, B, and C. This is little a, this is little b, and the whole bottom is little c. Now, from vertex B, I'm going to drop a perpendicular line. We'll call h the height. Well, if I call this piece x, then the rest of it is all of b minus what I've already used. After all, what do you add to x to get b? Well, first you have to add b, so I have the b. But then you need to take away the x, so I only have b. So you add b minus x to x. So that's why I labeled it b minus x plus x. b minus x and x. Now, Pythagoras would say in the left triangle, triangle 1 and triangle 2, in triangle 1, Pythagoras would say that x squared plus h squared is equal to c squared, because it is a right triangle. He'd also say in the second set of the right triangle that x squared plus h squared is equal to the hypotenuse squared. Well, if we subtract, the h's disappear. So you have x squared minus b minus x squared, and this is c squared minus a squared. The left side, we have the difference of squares. Whenever you have one thing squared minus another thing, you can write down the two things twice. In one bracket you can add, in the other bracket you could subtract. So first I'll add, and in the other bracket I will subtract. And the right side doesn't change. On the left side we just get b, because x plus negative x is 0, plus the b. And in the right bracket we get x minus negative x, which is x plus x. Let's not forget to take away the b. And the right side is still the same. C squared minus a squared. Let's do some cleaning up here. If we distribute, we get 2bx minus b squared, and this is c squared minus a squared. So I want to rearrange. I want to swap these two. I want all the a, b's, and c's to be positive, or the a squared, b squares, and c squares to be positive. So we have 2bx plus a squared is equal to b squared plus c squared. And then I just want to have a squared on the left side. That is, this term, which is understood to be positive, I bring it to the other side. Okay. Now, thing is, what is this x all about? Well, let's look at triangle 1 again. Triangle 1. If we take the cosine of angle A, we get the adjacent divided by the hypotenuse. That means that c cosine A is x. Okay. Alright, can deal with that. So I get a squared is equal to b squared plus c squared minus 2b, and x is c cosine A. This is one form of the law of cosines. Now, notice that I drew I drew the altitude at B. I drew it at B. Well, I could have drawn it at A, or I could have drawn it at C. And if I had done that, the only thing that would change is the order of A, B, and C. Now notice that what's being multiplied here and here are those values. And the cosine of the angle is big A. Not little a, but big A. So if I have little b, this is equal to a squared plus c squared minus 2 times those letters times the cosine of big B. Or, if I had c squared first, that would equal a squared plus b squared minus 2 times ab, cosine of not little c, but big C. Those are the 3 forms of the law of cosines. Those are the 3 forms. Okay. So, let us try to work out a problem. Suppose you come to know that this angle is 35 degrees. This is unknown. This is 10, and this is 20. Now, we can try to use the law of sines. You have a pair, and it includes the unknown. But you don't have another pair. You have 10, but you don't have that angle. You have 20, and you don't have that angle. And you can't get the angle unless you use the law of cosines, to be honest. Now, what you do have is either you have this angle or the side opposite it. And you have the 2 sides that make up the angle. You have the 10 and the 20. That screams for law of cosines. Let's go over it again. With respect to this angle, you need to either know the angle or the side opposite it. You need one of those two. And what makes up the angle, the 2 sides that make up the angle, you're given law of cosines. Let us label this A, B, C. And we want the angle to be big A. So that tells me that little a squared is equal to the sum of the squares of the other letters minus 2 times BC times cosine, not of little a, but big A. Well, I'm given everything. Now remember, this is A. B is opposite angle B is little b. Opposite angle C is little c. So it's 20 squared plus 10 squared minus 2 times 10, 2 times 20 times 10. Times 10, cosine of 35 degrees. This is 400 plus 100 minus 20 times 10 is 200 times 2 is 400 cosine 35 degrees, and this is 500 minus 400 times 0.8192, which is approximately 172.3392. But that's A squared. A is going to be the square root of that. which is 13.1278. So since they asked us to find x, so let's call it x. The instructions were to find x, to find that value. And we did, and we used the law of cosines to do so. Let's try this problem. You have this triangle. You're given these two sides and the angle in between them, or the side opposite it. That's what you want. Now you can label this any way you want. A, B, C. So opposite angle B is little b, opposite angle C is little c, and of course opposite A is angle A. So the unknown, whether it's the side or the angle, that little letter goes first, a squared. And like the Pythagorean theorem, it equals b squared plus c squared. But then you take away 2bc cosine of big A. Okay. So a squared is equal to 10 squared plus 16 squared minus 2 times 10 times 16 times the cosine of 98 degrees. And if you crank this out, you would get approximately 400.535. Well, that's what a squared equals. So a is going to be a little bit more than 20. Because 20 squared is 400, and this is just a little bit more than 400. So it turns out it's very close to that value. Let's try another problem. This time we want to find out what x is, and we are given these three sides. But notice, again, we don't have repair. We have the unknown angle and the side opposite it, which is good to have one unknown. But we need another pair, an angle and the side opposite it, to use the law of sines. This one screams for law of cosines because this angle is made up of these two sides. Ooh, we have them. And between these two, only one is unknown. So AB will label it ABC. So this is little b, this is little a, and that's little c. And since we want big A, we'll start off with little a squared. Little a squared is equal to b squared plus c squared minus 2 times bc cosine of big A. Well, I'd bring these actually, I would swap those two terms because I hate having negatives. I have 2bc cosine A is equal to what was originally on the right side, and I bring over the a squared as minus a squared. What I mean by positive is, now when I divide by 2bc, I have cosine A, not negative cosine A, cosine A. Divide the other side by 2bc. So cosine of A is this. Let's find out what this is, and then we'll find what A is. Or you could do it, you can solve for A right away actually. You could interchange these two things whenever you want. Cosine of b squared plus c squared minus a squared over 2bc is equal to a, so long as you write inverse. So a is the cosine inverse of b squared. Well, let me write it down here. B is 4, a is 5, and c is 3. Okay, so you get 4 squared plus 3 squared minus 5 squared over 2 times b times c. This is cosine inverse of 16 plus 9, 25, minus 25 is 0. 2 times 4 is 8, times 3 is 24. But 0 over 24 is 0. And this is asking the cosine of what angle is 0. The answer is 90 degrees. So we found A, and that's what they asked us to find. But they also called it X. So X is 90 degrees. Now, why is this an obvious answer? So we want this angle. Well, we know that a right triangle is 3, 4, 5, where 5 is the hypotenuse. I mean, after all, 3 squared plus 4 squared, which is 9 plus 16, or 25, it does equal to that squared. So, right off the bat, we know this is 90 degrees because it's a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. There's no way that that angle opposite the 5 can be anything but a right angle. In other words, you can't have a triangle like that where this is 3, this is 4, and this is 5, and that's not a right angle. It's not gonna happen. Okay? This will not happen. This will happen. That's a right angle. 3, 4, 5. It's gonna be a right angle. So in this problem, from the very beginning, if you noticed 3, 4, 5 is a Pythagorean triple, which means that 3 squared plus 4 squared does equal 5 squared. The longest side opposite it is a right angle, 90 degrees. Now, what I would like to do is talk about that a little bit more. We know, for example, that a squared is equal to b squared plus c squared minus 2bc times the cosine of big A. Well, if big A is 90 degrees, we get a squared equals b squared plus c squared minus 2 times b times c times the cosine of A, which is the cosine of 90 degrees, which is 0. You multiply those four numbers, you're going to get 0. And the right side is just b squared plus c squared. That is, the law of cosines does live up to the Pythagorean theorem. After all, when we went to prove or derive the law of cosines, we made a right triangle. And then we used the Pythagorean theorem. One leg squared plus the other leg squared equals the hypotenuse squared. That was from triangle 1. From triangle 2, we did one leg squared plus the other leg squared equals the hypotenuse squared. This squared plus h squared is equal to the hypotenuse squared. So yes, the law of cosines is going to live up to the Pythagorean theorem. That's where we got it from. Also, whether we got it from the Pythagorean theorem or not, you can't have two laws that contradict one another. In other words, if A is a 90-degree angle, you couldn't get, 2A. You couldn't get that A squared equals B squared plus C squared plus 2A. That would contradict the Pythagorean theorem. Okay, this completes the section on law of cosines, but I do want to reiterate that you use the law of cosines if you know, say, this leg and that leg. You know the lengths of these two legs, and you're given one of those two, and you want to know one of them. If you're given this one, you can find that. If you're given that one, you can find angle C. Okay, so if you're given two sides and their included angle, you can find the opposite side. If you're given all three sides, you can find the opposite angle of your choice. You can find the opposite A, you can find the opposite B, or you can find the opposite C. You can find any of the angles if you're given all three sides. But if you're given two sides, and you either want to know the third side or the angle that made up those two sides, law of cosines. You need to know that, so when you're given the information, you go, oh, I'm given two sides and I want to know the angle in the middle of those two sides, law of cosines.